Hey guys, I'm just getting stuff set up. I accidentally turned off the computer and had to restart everything. So I'm in the process of re-putting everything up, but I didn't want people to show up and then be like, what? So that is what I am working on. Give me a second. Let's see here. Okay, we don't need this. This is going on already. This we don't need. Let's open you up. Drag you over here. Excellent. This is going to go here, down like this. Almost ready. Perfect. Okay. I don't know what this magnifier is about. We're going to screen share, and there we go. Okay, so we'll hit screen share, but it's not screen sharing quite yet. Let's see. Do. Now it says there was an error opening our file. Well, that's not helpful. Give me a second, guys. Let's see. Open file. There we go. Okay, so let's get started. Yay! You even beat me to it. That's awesome. Perfect. Okay, so I am going to go ahead and get started. We have a lot of content to do. I will tell you sometime after 8, I'm going to have to step out for a second because Freddie is here and his dad's going to come pick him up. So I have to bring him outside. All right, so there's a whole lot going on with this information. If I had you on Friday, then you already have the questions that you need because I gave them to you. If I did not have you on Friday, they were in the email I sent to your folks. Let me see if I can. I don't know if I can upload it into the comments right now. So let's see. You know what? Let me post it to Google Classroom so you guys have it. Just in case, because as I know some of you who are logging in might not be a student that I saw yesterday. So we're going to do that. Let's click to everyone. I should have thought about this ahead of time. I did email it to your parents, but that doesn't mean your parents necessarily printed it out and gave it to you. So let's take a look. EOC. And you know what? I'm going to post the stuff we're going to, I'll post both. I'll post today's and Sunday's. So questions for Saturday and Sunday. Okay. And then you guys should be able to download it there. All right. So let's go ahead and get started. I did not post the notes. I'm pretty much just posting the EOC questions that you guys are going to have to do. All right. Let's see. Where's my little... Perfect. Okay, so you do have some equations that you have to memorize, but most of the main ones are going to be on the formula sheet. When we come to volume and density, this is what we're looking at, these right here. We will use distance formula, perimeter, and down here there's area. We will use those occasionally, but most of what we want are right here. We might also use Pythagorean theorem in the spirit of transparency. These shapes you drew in your books already. We know that a prism, the formula for the volume of the prism is V equals B, big B, H. And that pretty much big B just stands for length times width. So if you forgot that, you might want to put it in. The cone is volume equals pi r squared, which stands for the radius, but then times the height. The sphere is 4/3 pi r cubed. This is going to be 1/3 pi r squared h. And this is 1/3. Why am I rating pi? 1/3 length times width times height, or 1/3 big B times height. All of a sudden, yeah, those are the right formulas. Again, you don't have to really know these. These are going to be on the formula sheet. Okay. Here are things that you do need to know. I am going to show you a cross-section video because we only talked about like certain of them. I don't even have cube up here. We have rectangular prism, but cube has some additional shapes in it that we could cut differently. Rectangular prism has a couple different ones, but this is just a basic understanding. Horizontal, vertical. Angled is kind of tricky. There's some other angled ones that cross sections that we haven't really talked about, but these are good ones to know. And you'll see why coming up. So let's take a look here. In this handwritten, this is a hand drawing of a mountain. It says, explain which geometric shape could be used to estimate the total amount. Well, I think we can agree it's either going to be a cylinder or a cone, or it's going to be a pyramid. I hope we can agree that it's not going to be a pyramid because a mountain doesn't typically have a square base. Typically, the bases are curved. So here, explain which geometric shape could be used to estimate the total amount of earth it's made of. I would say the mountain most represents a cone. Now, I doubt that you would see this exactly like this on your EOC, and you definitely won't see it on your district assessment because your district assessment is all multiple choice, and your EOC, I wouldn't think that they would choose an extended response question like that. Here, what is the volume of the cone shown? This is a trick question. It's a trick question because we don't know the height. What they give us is they give us this diagonal. So the first thing that we're going to have to do is determine this height, which I'm having the awfulest time right here. We need this value here. We have the diagonal, but we don't have the height. This is like a DOK 2 or 3 level question, so it's kind of challenging. First, you're going to do a squared plus b squared equals c squared. It's probably a D depth of level, DOC, depth of knowledge 2. We know that the hypotenuse is 17 because here's the right angle. And with Pythagorean theorem that we did in class, we know that the opposite is 17. Now, it's tempting to write 16 in one of these parts, but we really shouldn't because 16 represents the entire diameter. We only want half of it. We just want the radius. So we're going to do 8 squared. We don't know the height. That's our x. This is going to be 64. I don't remember 17 squared off the top of my head. Prince, what do we do with that calculator? Here it is. Okay. 17 squared gives us 289. When we subtract 64 from both sides, we get x squared equals 225. And then when we take the square root of 225, wow, I really made that awful. There we go. Oh, we get 15. I knew that in my head too, Michelle. Okay, so now we know x is at 15. Now we can use the formula for a cone, which is pi r squared height. We have pi, our radius is 15 squared. Oops, that's not true. Our radius is 8 squared, which we got here, and our height is 15. 8 times 8 times 15 is 960 pi. In this case, I would just leave it in terms of pi, namely because they have, I'm just making sure that our answer is correct. Oh no, what did we do differently? Oh my gosh, you know what I forgot to do? That's why I was doing it. I was like, man, something doesn't seem right. I forgot to multiply by 1/3 because we're not doing a cylinder. We're doing a cone. Oops. Okay, we got to do 1/3 because it's a cone. So then we're going to do 960 divided by 3, and that's how we get 320, which is what I remembered from the other day as the answer, but I didn't get here. All right, there you go. There's your thing. So point, use the formula sheet. Don't do what I just did. Growth mindset, we'll use the formula sheet more often. A sphere has a radius of 3 feet. What is the volume of the sphere? Well, we know the formula for a sphere. This one I just looked up on the side. is 4/3 pi r cubed. We're going to take our 4/3. This is nice because they tell us its radius already. If they told us it was a diameter, we would have to, of course, divide by 2. Here we're going to have 4/3 times pi times 3 times 3 is 9 times 3 is 27. I'm just going to do some fraction reducing. I can take 3 here, take 3 here. This is going to be 9. So I'm left with 36 pi. And then we should, of course, put our label feet cubed there. Next question. I'm just trying to go fast because there's a whole lot and I don't want you all to get bored. And you can always rewatch it later if I go too fast. Here's my calculator. A cylinder has a radius of 10 and a height of 9. So let's just take care of that right now. We have a cylinder. Here's our cylinder. It has a radius of 10 and a height of 9. A cone has a radius of 10 and a height of 9. Show that the volume of cylinder is 3 times the volume of the cone. I would just solve it. Here you've got pi times the radius squared times the height. It's going to give you 900 pi because 10 times 10 is 100. 100 times 9 is 900. Here the formula is 1/3. Remember, I screwed up on the last question. Pi r squared and the height. So we've got 1/3 times pi times the radius squared times the height. I can do this math right here. So we're going to left with 300 pi. So we've pretty much just shown that. You could just write something like 300 pi because it says 3 times 3 equals 900 pi. If you want to be, really fancy, you could have written cone and cylinder. Again, I wouldn't suspect you necessarily see a question in this style on the EOC. And again, you definitely won't see it on the district assessment simply because it's a word problem. And I don't know if they would have you spend that time on a word problem with it looking exactly like that. Next one, what is the volume of a cylinder with a radius of 3 and a height of 9.5 inches? So we're going to take here and we know it's a cylinder. So we've got our pi r squared height. Pi times 3 times 3, radius of 3, a height of 9/2. Okay, a couple ways to do it. I prefer just to do the math. 3 times 3 is 9. 9 times 9 is 81. So you have 81/2 and then the pi. So there's the answer. The other thing you could have done is turn this into a decimal. You really didn't have to pay attention to the pi's because do you see how all the answers have pi in it? So really the pi didn't matter. It just was there for the, for help. But that would be the best way that I could think of to do that problem. And again, I apologize for going fast. I'm just trying to get us through as much of the content as we can so that we can be successful coming up. Next, we have the shape. If the plane in a figure is parallel to the pyramid, which best describes the shape of the intersection? This is kind of like a trick because I taught you that if this says square, the answer is a square. Square is not one of the choices. So your best guess is a rectangle. And you can see how they have the rectangle there for you. That's an easy question. Let's hope they give you one like that. A company needs to package this bell in a rectangular box. Well, we know that bells have circular bases. So we know that if it's 6 inches from there to there, we also know that from here to here, in essence, it's 6 inches. So I want you to picture the base of it being 6 by 6. Okay. The height is 8. So it says, what are the smallest dimensions, length, width, and height? So your smallest dimensions would be 6 inches for the length. Okay, again, 6 inches for the width. And then 8 inches for the height. When I did this problem after school, we actually solved the volume. And you don't need to solve the volume. It's kind of tricky. So side note, don't solve for volume, just solve the problem. Okay, let me make sure. Yep, 6 by 6 by 8. Had to check my notes. Don't want to steer you wrong. Next question. Here's a square pyramid packaged inside of a box. is then filled with foam. How many cubic inches of foam is needed to fill the space around the pyramid? This is my math hack way to do it. You could find, well, let me show you the long way. The long way is find the volume of the cube. And we know that the volume is length times width times height, which is going to be 5 cubed. So you have volume equals 125. You could also then find the volume of the pyramid, which is 1/3 base times width times height, length times width times height, whatever. So then you're going to get 1/3 of 125 because those numbers are the same. And on our trusty calculator, we get 41.67. Now that would fill up the cube. So we need the space that's not on the cube, which is this space. So the long way then would be to do 125, subtract the 41.67, and that's where we're going to get the 83. This is my math hack. You could have done it. Well, we know that the formula for a pyramid and a cube is basically the pyramid is just 1/3 of the cube. So I would have just gone right away, taken my 125. And if we know 1/3 is inside the cube, we know 2/3 is not inside the cube. So I would have just done 125 times 2/3. And that would have gotten us 250 divided by 3, which also gives you your 83.3. Okay, so either way that you do it, whether you do the official way where you find the volume of the cube and then you find the volume of the pyramid and then you subtract, or whether you do it my math hack and know that relationship. That same relationship is also true between a cone and a cylinder, that the cone is 1/2 of the cylinder. So you could have, that would also work for that problem. All right, Cavaliers Principle. I know some people get really confused on this because they focus on the shapes. Don't focus on the shapes. Basically what you're thinking is when you have two parallel lines, here's a parallel line, here's a parallel line. That distance is called the height. So here's a parallel line or even a parallel plane. And basically, here it is, parallel planes. Okay, that means height. So if you have two solids are between parallel planes, height, then you also have here parallel planes and you have areas that are equal. Okay, that is kind of how it looks. And so Cavaliers Principle says, whoops, we have a guest. Hello. Basically, it says that if those areas are the same and the heights are the same, then the volumes are also the same, even if the shapes look completely different. So let's take a look at some EOC level questions. Here we have a cylinder A and cylinder B. What is the volume of each? Well, some people might be like, I can't do cylinder B simply because cylinder B is slanted. I don't know the formula for a slanted shape. Simply because this and this have the same diameter, hence the radius is the same. And they have the same height, or more specifically, they lie between parallel planes. Cavaliers Principles, parallel planes. All we do is use the normal formula. Pi r squared, height. Konnichiwa, hello from Georgia. We're practicing for our state test in Georgia. So welcome. So here we have our 10. Now, don't put the 10 in because 10 is the diameter. You want to only put in the radius. So here's our radius. Okay. So 10, half of 10 is 5. So now we can just go right in. Pi times our radius squared times our height, which was 12. So we've got 25 times 12 times pi. And then 25 times 12, 300 pi. And because of Cavaliers Principle, which says that if we have parallel planes, Cavaliers Principle, that height is the same as long as the areas are the same all the way down, even though it's slanted, it still works. So this is going to be 300 pi as well, just like that. Next. All right, lovies, I know you guys are going to look at it again. Here's a perfect example. Jason constructed 2 cylinders using solid metal washers. Good for you, Jason. You must have been really bored. The cylinders have the same height, but one of the cylinders is slanted as shown. Which statement is true about Jason's cylinders? Well, it says the cylinders have different volumes because they have different radii. We're going to assume that because they were solid metal washers, the radii were the same. Okay, so it can't be A. The cylinders have different volumes because they have different surface areas. Surface areas has nothing to do with volume. We've already know that. It's not going to be that one. The cylinders have the same volume because each of the washers has the same height. Maybe. It doesn't mention anything about area. That's the only thing. I like how it says height, but it doesn't necessarily mention that the areas are the same. The cylinders have the same volume because they have the same cross-sectional area at every plane and parallel to the bases. Yay, that's the answer. Parallel to the bases. Every plane parallel to the bases. Parallel, 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 parallel. That is Cavaliers Principle. Score. Okay, next one. All right, so now we're going to talk about density. So density is mass divided by volume. You probably know that from physics. When it comes to population, it's pretty much the number of items divided by the area. This next problem, if I remember correctly, was a doozy, but I know we can work through it and do it. Oh no, thank goodness it wasn't the doozy. The doozy is coming up with Joe's peach trees. Here we go. So it says the city has a population of 6,688 people. The area of the city is approximately 7.27 square miles. Look, it even tells you people per square mile. So that tells you per, all a purple means is to divide, because it says per, we're going to divide people divided by square mile. Okay, so we've got 6,688 people, and we're going to divide it by 7.267. Get our trusty good old calculator. Hello, calculator. So nice to meet you. Divided by 7.267. And we're left with 920.324. I wouldn't suspect that they want us to have half of a person. So I'm going to lean towards saying there's 920 people per square mile, because it's not like you can have 0.324. So we're going to be 920 people per mile. Done. Next. I don't remember why I left this up here. A construction company is preparing 10 acres of land for a new housing community. The land contains large rocks that need to be removed. A machine removes 10 rocks. Oh yeah, I didn't like this question. From 360 square feet of land. So I'm going to explain to you how we did this problem. First, we have to figure out how many feet there are. So because we know there's 10 acres of land, and because we know 10 acres of land, that 1 acre is 43,560 feet, we're going to take 10 and multiply it by 43,560, so that we know that this construction company is preparing 435,600 total feet. Now that we know how many total feet we have, we know that this magic machine removes 10 per 360 square feet of land. So picture, if this is all the land, we know that each one of these boxes would represent 360 square feet. So now we have to figure out how many of these boxes are in his land. So to do that, we take this total number of feet, we divide it by 360 feet. So we know how many total hunks of land there are. When you do that math, you get 1,210 parcels. So there's would be 1,210 of these, which I clearly am not going to be drawing all of those for you. Now that we know that there's that many parcels of land, then we're going to multiply by 10 to get the total ones. Let me talk you through that problem again. This construction company is preparing 10 acres of land. So we know that 1 acre is 43,560 feet. So we multiply all those things together. What? Now that we have those. Next, we're going to take our magic 360 feet. Where do we get the 360 feet? We got it from right here. That tells us that each area that this machine goes to clear 10 rocks is worth 360 feet. So we want to know how many pieces of 360 feet are in here. All we're going to do is divide. How many total feet divided by 360? So now we know that there's 1,210 parcels of land. Now we have our 1,210. We know the machine moves 10 rocks per parcel. So that's how we get this total number. I said in class, hold on. Hey, Hez. Yes, sir. Yes, on probability. Now I lost. Escape. Well, that's not cool. I'm joining and then all of a sudden I can't get out. Oh, that's probably why. Okay. And now we get your U code. Lovely. Okay, so next, let's keep going. Joe, this is the Peachtree Problem, which was a real rough thing to work on. We've got Joe counts 250 peach trees on 25% of his land that he owns. He's determined that there's 10 trees for every 1,000 square feet of land. How many acres of land does Joe own? So first of all, we know there's 250 peach trees on 25% of the land that he owns. So we're going to work kind of backwards. He's determined that there's 10 trees for every 1,000 square feet. I'm trying to remember how someone else did it in after school review because they did it way easier than I did it. Okay, so if we have 250 peach trees, pen tool, and we divide that by 10, okay, for every 1,000 square feet, we know that there's 25,000 square feet of land. Okay. Then if you take your 25,000 square feet of land and then you do the division, we're going to do that divided by 43,560 square feet because our goal is to get the acres. So basically I took my 250 and divided it by 10. That gave me 25. Then I multiplied 25 times 1,000. You know, I'm going to start over because let's just write it in smaller. So we have 250 peach trees divided by 10 trees total for each 1,000 square feet. So 1,000. So that means that we have 25,000 square feet. Because I did 25 times 1,000, which equals 25,000 square feet. Then I take this number and I divide it by acreage. When I do that, I think I get like 0.8. It's been 2 days since I did this problem, so I better do the math. 43560. Oh no, we don't get 0.8, we get 0.56, which is why we did the math, 0.56. So that equals 0.56. But that just represents 25% of the land he owns. So we know if 25% is 0.56, and this is where his peach trees are, we know that each of these other pieces is also, give or take, 0.56. When we do the math, it's 0.57. 57 times 4, we get 2.28, which would round to 2.3 acres of land. Trash new. All right, now we've officially finished volume and density. We're getting into, circles. I did not cover circles after school. So this is hopefully where you're going to jump in. A couple things. Standard form. Okay, we know that we have to go and use the formula. The formula is on the formula sheet. The main thing to remember is this. You're going to end up switching the signs of the center. Whenever you go from formula to center, the signs switch. Whenever you go from formula to radius, you're going to take the square root. Whenever you go from radius to formula, you square it. That's the core concepts that you're going to have to remember. And then you had this very long way to do standard form. And then you had my math hack. I love my math hack. This is how it is. First, you group the X's, leave a space. Group the Y's, leave the shapes, and bring the constant to the other side. Then you're going to set it up. You set it up by just writing everything that's down for the circle formula. Then we're going to go down, dividing by 2, up by squaring it. And then whatever we put on one side, we also put on the other side. So let's do some practice problems. Oh, graphing circles, radius, center point, blah, blah, blah. Diameter, slope, triangles. I want to do a problem. Here we go. So first things first, it gives us the center of the circle and it gives us the radius. We know that anytime we go from the center to the formula or the formula to the center, we flip the signs. So this is going to end up being X. This is positive 4, so I'm going to put negative 4 squared. Y, this is positive 5. I'm going to flip the signs. Anytime I go from formula to center to formula, I flip the signs. And then anytime I go from the radius to the formula, I square it. So that actually it's 4. So I'm just going to actually just do 2 squared. Bump, 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 bump. Pen 4. And that would be your equation for that one. Trash. Boom, 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 boom. Next one. Center and radius given this one. Okay, here's kind of tricky. I really haven't spent too much time showing you this one. What I need you to do is to make sure that you have x squared by itself, like there's no coefficient. So see how each of these things is divisible by 8? We want to make sure that it's just x squared, specifically 1x squared and 1y squared. That's the most important thing. So if we divide each of these things by 8, that's going to give us our new problem. Well, here the 8's cancel, so we're left with x squared. Here are the 8's cancel, so we're left with plus y squared. Perfect. That's what we need. Here we have negative 16 divided by 8, so we get negative 2. The x comes down. Negative 32 divided by 8 is negative 4. The y comes down. Positive 24 divided by 8 is positive 3. 0 divided by 8 is 0. Now I have it in standard form, and now we can do the hack. We're going to group the x's, check. We're going to have x squared minus 2x, leave a space. Remember, it's always going to be a plus sign because we have to square going up, and anytime you square something, you always get a positive number. Group the y's, leave a space. Take the constant, move it to the other side by switching the signs. Now we're going to set it up. We have x blank squared plus y blank squared equals, and we know the radius squared. So now we're going to put in our numbers. Well, half of negative 2 is negative 1. Negative 1 times negative 1 is positive 1. If I had to put a plus 1 here, I put a plus 1 here. Half of negative 4 is negative 2. Negative 2 times negative 2 is positive 4. If I put a positive 4 here, I put a positive 4 over here. Negative 3 plus 1 is negative 2. Negative 2 plus 4 is positive 2. So now I've done the equation, but I'm not where I need to be. Where I need to be is I need to be able to find the center and the radius. Anytime that we go from the center to the radius or the radius to the center, we always flip the signs. So we are now going to have our center at 1, 2. Our radius, anytime we go from radius to formula, or specifically, I'm sorry, formula to radius, we take the square root. So our radius is the square root of 2. And let me just make sure that that's accurate. It is accurate. Woohoo! What? Next. Hey, 17 questions left. Yay, us. All right. That was a little bit silly, but it's the truth. Here we go. So here we have, what is the equation for the circle with a center of negative 2, 3? Okay. Well, remember, anytime we go inside, we always change the signs. Negative 2 becomes positive 2 squared. Y becomes negative 3 squared. And our radius is 3. So remember, anytime we go from the radius to the formula, we square it. 3 squared is 9. Okay. You could do it the long way. I would prefer to do it the short way. We take our plus 2. All we do is we're going to double it. So we've got x squared. Remember, if we divide by 2 going down, we're really going to be multiplying 2 to go back up. So this is going to be plus 4x. And then to get our squared, we still are going to do 2 squared, which is 4. Now we've got our y squared. We're going to double it to figure out what goes on the side. Square it to give the extra part, and then equals 9. Here's our catch. We added a plus 4 and a plus 9 here. So we're going to add a plus 4 and a plus 9 here. Okay. Then that's pretty much what your answer is. X squared, y squared, y squared. So right away we can eliminate B and D. Here we have positive 4x. I'm going to actually just cross them all completely out so I don't get confused. Both have positive 4x. Both have the 9. Oh, you know what? Let's see. No, I still want to do it that way. 18 and 4. Hold up. No, but take that off. I was wrong. Here we have our 13. When we add our 9 to both sides, that gives us our 22. And the reason why we have to move that 9 over, no way, that gives us 4. We're subtracting 9. What was I doing? Don't listen to me. I was rushing. This is what I get for rushing. I'm going to go back over here. Okay. We don't have to put pen tool. I apologize. We don't put the +9 and +4 on this side, and we don't do it because it's already here, right here. We're not adding any extra information. So when we combine these values, we're going to have our x squared. We're going to have our y squared. So we did that. Check, check. We're going to have our +4x. Check. We're going to have our -6y. Check. Now we're going to combine these and get +13, and these still equal 9. The issue is, and if I gave you the wrong answer in class, I apologize. The issue is now that we have the 9 on this side, we have to make it equal to 0. So we're going to subtract 9 from both sides. When we do this, here's our 0, and this becomes +4, which is why it's choice C. Woohoo! Did I have a Saturday night brain fart or what? What is the center of the circle given by this equation? Here's our math hack. Thank goodness they don't want the radius. All we do is we divide these numbers by 2. X, this divided by 2 is going to give us -5. And that's going to be squared. Y, there's no Y term, so it's going to be 0. So now the only thing, because we know our Y term is 0, it can't be choice B and it can't be choice D. The trick is anytime that we go from equation to center or center to equation, we flip the signs. So this says -5, but really our center is +5, 0. So it's choice A. Next, slope. The slope formula is this I took right from the book. So this is what the state of Georgia says is important to you. We have our slope. A line with a positive slope stands up. Negative is down, 0, and undefined. Here's other things that they want you to know. To prove a triangle's isosceles, you can use a distance formula. This pretty much is that long quadrilateral qualities page that I made you all write, and you got kind of angry at me for making you write. Here it is right here. That's what you need to know. Other tips in terms of partitioning a segment and directed line segments. And frankly, I don't think I'm even going to go over those tonight. Quadrilateral ABCD has vertices such and such. Is it a rectangle? Explain. How do you know? Okay. First things first, we need to determine if it's a parallelogram. If it's a parallelogram, then the diagonals bisect each other. If the diagonals bisect each other, then the midpoints of the diagonals are the same point. Okay, so first things first, we're going to see, is this baby a parallelogram? This is probably going to be one of your extended response questions is what I'm going to guess, because I can't think of how else they're going to do it. So we're going to check the midpoints. Okay, first, if here is our quadrilateral, ABCD, our two lines are going to be BD and AC. So our midpoint for AC, remember we add the x's, divide by 2, add the y's, divide by 2. So you've got -1 + 4 divided by 2. It's going to give you 3/2 for our x. 3 + 3 divided by 2 is just going to give us 3. We know that, so I'll put that here. Now we've got our BDs. We've got 3 + 0, which is 3. And then, hold on. Divide by 2, 3/2. There's my brain fart. 5 and 1 is 6. 6 divided by 2 is 3. So they do have the same midpoint. So we know the shape is a parallelogram. So yes, it's a parallelogram. Now we're going to look at slopes. Okay. The next thing is, it says if the diagonals are, well, you could also do the diagonals are congruent. I probably would just do, yeah, I probably would have just graphed it, but we can do if the diagonals are the congruent. The way that we're going to do that is use distance formula. So we're going to do, I'm going to do it my math hack way for distance formula. So now we're looking at diagonals congruent using distance. Okay, remember my math hack is you write them one on top of the other. So I'm going to do the C first. This is AC. BD will be 3, 5 and 0, 1. Okay, we know that we're going to do change, 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 right? So we're going to subtract. So this becomes plus, minus, minus. This becomes -5. This becomes 0. We square them. This goes up to 25. The square root of 25 is 5. So the distance of that line is 5. Here, we're going to subtract. So we're going to change. 3 minus 0 is 3. 5 minus 1 is 4. 3 squared is 9. 4 squared is 16. Add them up and get 25. The square root of 25 is 5. So now we know the diagonals are congruent. It is a parallelogram because the diagonals are congruent. So it's a parallelogram because the mid diagonals bisect each other. And it's a rectangle because the diagonals are congruent. That's a long problem. I'm guessing this might be one of the EOC long questions, but that's just a guess. I have no idea. Circle C has a center of -2, 3 and a radius of 4. Does the point -4, 6 lie on circle 3? I would just say because this says it's a radius of 4, let's just use distance formula. If the distance between these 2 points is 4, then it is. So we're going to use distance formula. And we're going to check if it equals 4. So we've got -2, 3, -4, 6. We're subtracting it. And I told you change. -2 plus 4 is +2 squared, which is 4. 3 plus -6 is -3. -3 squared is 9. 9 plus 4 is 13. The square root of 13 is less. Will end up giving you 3 point something. So it does not lie on the circle. It actually lies in the circle. Let's see. Yep. All right. That's it. Cool. Next question. Trash can. The line P is represented by the equation y equals 4x plus 1. What is the equation of a line that's perpendicular to line P that passes through that point? So first of all, we know we're going to have perpendicular. So if our slope is 4, we know our perpendicular slope, hi Ariana, is -1/4. So now we're going to use y equals mx plus b. Okay, we know that this is the point that we care about. So we're going to put in 5 for y because 8 is our x and 5 is our y. We're going to put in our new slope, our perpendicular slope. We're going to put in our x term, and we're going to put in a plus b to find the b value of y equals mx plus b. You also could do point slope formula. I just say don't bother doing that. It's way easier to do this. 5 equals -1 times 8 is -8. Divided by 4 plus b, this becomes -2. And then we're going to add 2 to both sides. So we get 7 equals b. So now that we have our slope and our intercept, we can write our line. Y equals -1/4 x plus 7. And that, my dear, is our equation. Okay, again, I know I'm going fast. I'm just hoping that you watch this video again. Yep, -1/4 x plus 7. We got it right. Next. What is the value of n for these lines if they are perpendicular? Well, we know that the two lines will be perpendicular when the slopes are opposite reciprocal. So first, we're going to set them equal so we can figure out what the heck their slopes are. So first things first, we're going to find the slopes by solving for y. Okay, Prince, you okay, honey? Okay, we're solving for y. So first things first, I'm going to subtract 7x from both sides. That leaves me 3y equals -7x plus 8. Still need to get the y by itself, so I'm going to divide each term by 3. So I get y equals -7/3 x plus 8/3 for this equation. On my other side, I've got nx plus 3y equals 8. We're going to subtract nx from both sides. 3y equals -nx plus 8. Divide everything by 3. We get y equals negative n over 3 times x plus 8 divided by 3. Here's the catch. Most people think right away, well, I can just go ahead and solve this problem and it's going to be 7. Well, that would give you a parallel line. That would not give you the perpendicular line. In order for it to be perpendicular, negative n over 3 has to equal the opposite reciprocal of this. So the opposite reciprocal of negative 7/3 is positive 3/7. Now we're just going to cross multiply. Negative 7n equals 9. Divide both sides by negative 7. And so find the value of n. The value of n equals negative 9 over 7. And we got it right. When negative 9 over 7, when that's the slope, then we know those two lines are perpendicular. Okay, quadrilateral ABCD has vertices of blah, 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 blah. Prove that it's a rectangle. I almost don't want to do this problem, but we will do it. You can do it a couple ways. I say let's do it that the slopes are parallel. And not only are the slopes are parallel, the opposite slopes are parallel, let's also do it that the adjacent slopes are perpendicular. So first things first, let's draw our picture. Okay, so we need to first say that these are our 4 possible lines that we could get. Okay, so let's do the slopes first. AB is 3 minus 0. Remember, change in y divided by change in x, minus 3 minus 4. So that gives us 3 over negative 1, which gives us negative 3. BC is going to be 3, well, it doesn't really matter as long as they stay the same. 3 minus 1 divided by 3 minus negative 3. That's going to give us 2 over 6, which is going to give us positive 1/3. CD is going to give us 1 minus negative 2 divided by a negative 3 minus negative 2. This becomes positive. This becomes positive. That's going to give you 3 divided by negative 1, which equals negative 3. Last and not least, we have 0 minus negative 2, 4 minus negative 2, which gives you 2 over 6, which gives you 1/3. So now that we have those slopes, we can simply say that AB is parallel to CD because the slopes are the same. We can say that BC is parallel to AD for the same reason. The slopes are the same, so this makes both. And then we can say that AB is perpendicular to BC. You should all have little lines over them because the slopes are the opposite reciprocal. And we can also say that for BC is perpendicular to CD. And that is it. It's a lot to do. It's actually shorter than what we did for the other. Remember, the other way to prove it was a parallelogram first, and then by doing finding the midpoint to make sure that the diagonals bisect each other. This is the problem from like 25 minutes ago. And then we end up finding the distance of the diagonals to make sure they were the same. In this case, we found the slope of the 4 lines and compared the slopes. Next question. I did it again. Given the points, A is negative 1, 2, and B is 7, 8, find the coordinates of the point P on the directed line segment. We have our 1/3 here. And it says it wants a ratio of 1 to 3. Remember, I told you that when it's a ratio, we're going to add. Here's our A, here's our B, and we add to find the points. So basically, we know that there's 4 points altogether. Our A plus B is that. So the formula that you can use is, this is the one I showed you. I showed you that this is right on the formula sheet. BX1 plus AX2 divided by B plus A. This is going to give us our first point. Our second point is going to be BY1 plus AY2 over B plus A. Great news. You don't have to memorize it. You just have to know how to use it. It is so important that it says A to B. So we got to make sure this is our A, our first point rather. Okay. So first things first is what's our B value? Our B is 3. So I'm going to write down 3. What's our first X? Our first X is negative 1. What's our A value? Our A value is 1. What's our second X value? Our second X value is 7. We're going to divide that by 1 plus 3 is 4. That's our first point. 3 times -1 is -3. 1 plus 7 is 7. Divided by 4. 4 divided by 4 equals 1. So we know our first thing is going to be at 1. Next, we're going to take our same thing, but for the y's. We're going to do our b value, which is 3, times our first y value, which is 2. Then we're going to add our a value, times our second y value, which is 8, divided by everything together. 3 times 2 is 6. 6 plus 8 divided by 4. 14 divided by 4. 7 halves, or 3.5. Let's see if it makes sense. Here's our 1. Oh, look at that, 3.5. It makes sense. So our point is 1, 3.5. More specifically, you could write 1 over 7 halves. Either way, it's the correct answer. Okay, we almost done? Find the area of ABCD given those points. The easiest way that we can do it is just do distance formula twice. For basically, here's our ABCD. We know the area is length times width. So I'm going to just find this one and this one. So I shouldn't have done X. Let's make that a Y. So AB, and then we're going to find BC, and then we're going to multiply. I'm going to use my math hack. -3, 0, 3, 2. This is my math hack for distance formula. Change, change, change. -3 plus -3 is -6 squared, which is 36. 0 plus -2 is -2. Squared is 4. So this is going to be 40. When we take the square root of 40. BC is 3, 2. C is 4, -1. And subtract, change, change, change. 3 plus -4 is -1. 2 plus 1 is 3. Square them. 1, 9, add them. 10, square root of 10. So now you have the square root of 40 times the square root of 10. You don't have to reduce anything. It's just straight up multiplication. The square root of 40 times the square root of 10. Well, remember, that's the same thing as 40, the square root of 40 times 10. The square root of 40 times 10 is 400. And when we use our calculator, you get an area equal to 20 square units. Trash. Next one. I'm sorry for going fast. I just want to make sure we can get all the questions in a reasonable amount of time. And I'm trusting you're going to watch these again and pause it. Which information is needed to show that a parallelogram is a rectangle? We already proved that earlier. A couple things. It's either that the sides are appropriately, opposite sides are parallel, and the consecutive sides are perpendicular. And then we also learned that the diagonals have to be the same. So, and the diagonals have to so same for the rectangle, and they have to bisect each other for it to be a parallelogram. Okay, so diagonals bisect each other. They do, but that's a parallelogram. It doesn't mean it's a rectangle. In order for it to be a rectangle, the diagonals have to be the same. So it's not, it's not A. Diagonals are congruent. Diagonals are congruent and the same. It's the same thing. Let's see if there's anything else. Diagonals are congruent and perpendicular. This would be if it was a rhombus. Diagonals bisect each other and perpendicular. Nope. It's all it is this one. Choice B. That's it. You just know it or you don't know it. Simple like that. What point is on the circle with a center of like that? A radius of 5. I think the only way that I would think about how to do this problem is just to keep doing distance formula because it's a multiple choice. There's probably an easier way, but on a Saturday night, that's the best way I can think of. So we're just going to use distance formula and see which one has a distance of 5. Okay, so I'm going to use my math hack. 3, -9. We're going to choose A first. -6, +5. We know we're subtracting. Change, change, change. This is 9 squared plus -13 squared. That's going to be a huge number, so it's not that one. B is 3, -9. So then we're going to do -1, 6. Change, change, change. This is going to be 4 squared, which is 16. This is going to be 15 squared, 225. That's too big. It can't be that one. Next, we have 3, -9. This is choice C. 1, 6. We know we're subtracting. Change, change, change. This is going to give us 2 squared, which is 4. This is, again, going to give us negative 15 squared, which is 225. So it can't be that one. It's got to be choice D, but let's prove it. Choice D, 3, negative 9, 6, negative 5. Subtraction, change, change, change. This is going to give us negative 3 squared, which is 9. This is going to give us negative 4 squared, which is 16. Add it up and get 25. The square root of 25 equals 5. Yay! I mean, the only other thing I could think of is we kept getting huge numbers at the end because of the Y's term. So we might have been able to see that was the only one that had a negative. But the only way I could think of to do that problem was just how we did it. Given these points, what are the coordinates of the point in the direct line? Separate the partition set in a ratio of 3 halves. All right. I'm kind of confused because they made it into a fraction. A is 3. It's got to be, they want you to do A is 3 and B is 2. Let's see. This one I have a question mark about. Because in theory, 3 halves. Yeah, let's see. Let's see how it works out. Okay, so we know it's B times x1 plus A times x2 over B plus A. Okay, so let's just plug it in. B would be 2. Our first x value is 2. Our A value is 3. Our second A value is negative 9 divided by 5. The good thing is I do have the answer key, but let's just see if it's 3 times there is negative 27 divided by 5. 4 plus negative 27 is negative 23 divided by 5. Is that one of our solutions? It is. It's choice A. And that's what the book says. Let's do the second one. For the second one, we've got our B, which is 2, times our first Y, which is negative 1, plus our, plus our A, which is 2, which is 3, my bad, times our second Y, which is negative 6, all divided by 5. This is going to give us negative 2 plus negative 18 divided by 5. That's going to give us negative 20 divided by 5, which is negative 4. So that's right. Yay, we don't have to worry about it being confusing. It's correct. Okay. The equation of the line is that lovely thing, which is the equation of the line that's perpendicular to the line A and passes through point. So first things first, it says perpendicular. So we know we're going to do the opposite reciprocal. So we know that our slope has to be positive 2x. Okay, so right away we can eliminate A and B. So now we're just going to plug it in. 0 goes in for y, negative 4 goes in for x, plus b. 0 equals negative 8 plus b. Add 8 to both sides. B equals 8. So then we have y equals, our reciprocal was 2, x plus 8. So it's choice D. Next one. Parallelogram ABCD has those vertices. Which equation would be used to prove that the diagonals bisect each other? Why did they do bisect each other like this? Typically, I would do bisect each other. I would do midpoint formula. So I'm kind of confused why they did distance. Let's take a look. 3, negative 1. 3 minus 1. Change in y over change in x. I would think that these don't make sense because we want to do straight lines. So I think right away we have to eliminate A and B because those don't make sense to me. The negative 1 and the negative 1 kind of does make sense to me. So let's see. And then why is it C over D? It's C over D. The difference is here. Oh, -1 minus -1 turns it into a positive. That's why. Oh, wait, but that's not true. Honestly, the answer to this one is C, and I can't tell you why. My brain is fried. I'm sorry. I don't even know why they would use it like this because I've only done it with midpoint. So this is my mistake. My bad. I apologize for that one. We're going to keep on and get the last one going. I'll have to look in that and maybe talk to you guys about it on Monday. Here we have what's the area of the triangle. We have base times height. It has the vertices shown. For our purposes, we're going to assume that this is the right angle right here. Okay. So now we're going to do just find the distance formula for AB. So we've got 1, 4, 4, 1, subtract, change, change, change. -3 squared, which is 9. 4 -1 is +3 squared, which is 9. That gives us the square root of 18 for AB. Because remember, the formula for a triangle is 1/2 base times height. So AB is that, square root of 18. BC is 1, 4. Nope. Why did I say BC? We don't want BC. We want AC. 1, 4 and -3, 0. Subtract, change, change, change. 1 plus 3 is 4. 4 minus 0 is 4. 16, 32, square root of 32. So now we've got the square root of 32 plus the square root of 18. This is when I would just use the calculator, honestly. I've got the square root of 32 plus the square root of 18 equals, wait, why am I doing plus? Oh, shoot. Why am I doing plus? It's multiplication. Why didn't anyone catch me? Times the square root of 32 times the square root of 18. 32 times 18 gives you square root of 576. Take the square root of 576. That gives us 24. And then the formula is 1/2 base times height. So half of 24 is 12. Wow. I definitely started losing my brain at the end. But is that our last question? Let's see. That is our last question. So we did it in 1 hour. You guys are amazing. I know it's going to take you longer to go through and really learn everything that we did, but that is at least how to do everything that we did. Tomorrow, 7 o'clock, probability. Be there or be squared. Peace out, guys. Bye. Okay.